Hyvää huomenta ja tervetuloa seuraamaan Opetustelevision viimeistä päivälähetystä, yhden ohjelman päivälähetystä tänä keväänä. Me näemme nyt toisen osan sarjasta Computer English. Tällä kertaa seuraamme koulutustilannetta työpaikalla. Siellä osanottajat odottavat englanninkielisen luennoitsijan esitystä robotin kehittämisestä. Eikä tuon esityksen seuraaminen olekaan yhtään niin vaikeata. Tekin voitte nyt testata, miten paljon ymmärrätte, mikä on oma puhevalmiutenne ja miten pitkälle oma rohkeutenne yltäisi. Tähän sarjaan toimitetun sanaston tilausosoitteen kerron heti ohjelman jälkeen. Ohjelman käsikirjoittaja on professori Heikki Koivo.
Now, where could they be? It's about time. Maybe the computer can tell me. Now, let me see. Oh, yes. It is the right time, but not the right place. Wonder where they are. Hey, look at that. That's where I should be. Oh, but they look so nervous to me. Maybe I better take the gown off. And I won't need a cap either.
Hi fellows, here's Dr. Paul Robot. He's one of the leading experts in computer vision and robot control.
Hello, everybody. Please, call me Paul.
Paul is robotics professor at the Artificial Intelligence Laboratory of Massachusetts Institute of Technology. Here is Jari, our research and development manager.
As everybody knows, we have decided to develop a robot that can see and feel. Not have feelings, but hold a glass without breaking them. Okay. Come on, fellows. I do not mean a toy robot. Our project team is assembled here. You can introduce yourself and your specialty.
Good idea. Hello, I'm Petri. I'm software engineer.
Hello, I'm Riku. I'm the programmer.
Hello, my name is Elina and I'm electronics engineer.
Elina is our hardware wizard.
Hi, my name is Pentti and I'm a robot technician.
Hello, pleased to meet you. I'm Tuomas and I'm marketing manager.
Hello, I'm Taina. I'm documentation engineer and project secretary.
A very impressive project team. Hey, you got a robot manipulator here. Is it also a member of the project team?
No, it's not. This is a standard industrial robot. There is a sleigh microprocessor to control each joint and also a master computer. Pentti, let us see it move.
Okay. It has programmed to do very simple work now. First I must call program name, how many times, then
Robots are pretty dumb creatures. They don't see nor feel anything. Oh, they can bump people and even hurt them.
Hey, let's sit down, please. It's safer.
Yeah.
In the movie Star Wars, Luke Skywalker had two robots, R2-D2 and C-3PO. How about this matter? Could we build something like those two?
No, not yet, I'm afraid. But maybe if we'll put you inside the robot. No, we'll build a vision system for the robot to see and finger sensing for it to feel.
You mean a TV camera with a computer attached to it?
That's right.
A vision system produces digital images of its surroundings.
And you could have pattern recognition capability too.
You know quite well what we want.
But all this requires a big mainframe computer. Maybe a supercomputer for number crunching.
And that'll cost a lot of money.
Real-time picture processing and control of a robot. How could we do it?
Good questions. I like your critical attitude. And let me explain. In a computer, we have a control unit, arithmetic unit, memory. We do things sequentially. If we add two numbers, A plus B, the computer will go to the memory location to fetch the number A, say 1.5. Then it will fetch the second number from another memory location, 2.5. Finally, it will add these two numbers and put the result 4.0 to a third memory location, and so on.
Paul, the old von Neumann computer architecture.
Exactly. But this is not fast enough for us. We are building a train which is longer the more operations we perform. So what we have to do is parallel processing. We will use several microprocessors. In parallel. There's one. And here is another one. In this case, we can perform our operations in parallel at the same time. So instead of a long train, we have several trains in parallel like this, and it will take less time. Parallel processing will do the trick for us.
Hey, that sounds really promising.
That's right. We will build an interface between the computer and the real world. In this case, it's the robot and the vision system. Voila, we have a seeing robot.
You make it sound so promising. What do you think of the saying, anybody and his dog can build a robot?
Oh, sure. But to make the robot intelligent and cheap enough to sell, that takes a lot of talent and skill. We need talent in software development, hardware development, marketing, programming, everything.
That's what we've got. Let's start working.
Okay, everybody. It's important that we work as a team. So let's go through the software management phases once again.
We'll start by defining what we want. Things like interface software, control software, and picture processing software.
Right. Software management is extremely important. After the definition phase comes a design phase. We'll decide what language is to be used. BASIC is too simple in this application, but Fortran, Pascal, C, Ada, and so on. And what operating system we'll use?
We have decided to use the C language with the Unix operating system as the development environment.
Then we will draw flowcharts.
No, that is old-fashioned. We must first define what sort of modules the program consists of. Like Jarmo said, interface modules, control modules, and so on. We start from the intelligence aspects of the robot and come down, the top-down method.
Nice going, Petri. First, we'll make a very careful design, and then we'll kiss. All the time we'll kiss.
What do you mean, kiss?
Kiss? Don't you know what I mean by kissing? Well, KISS is an abbreviation. Keep it simple, stupid.
I see. A key to a good software engineering.
Then we'll start programming, coding, and testing.
Right again. In this way, it's easier to test and find bugs in your program. Coding is done with our mainframe computer. Then we'll install the program in the robot's microcomputers and test it with the hardware. Yes, you seem to be catching on with the software management very well. But one thing that I forgot to emphasize is documentation.
I'm glad you said that. Most of the time people do not understand that it is essential to write down clearly what you have done.
Yes, and we have a versatile word processing system to aid in that. Taina, tell us how it works, please.
Sure. Edixworks works like a paper, pencil, and an eraser combined. Once we have written the text in a file, we edit it, add braces, remove them, and there is windowing too.
How about a demonstration?
Okay, our computer has soft keys for fast and flexible operation. They are displayed on the screen in Finnish. And here is our main text.
Wasn't it so that we could use 4 different windows?
Right, I can have up to 4 different windows and work each one of them separately. And finally, I can add the text that I have generated.
Hey, that's neat. Especially for a person like me who cannot type without making mistakes. For software development, we have here workstations that are connected to other computers via communications bus.
Here is the whole computer network, a local area network.
This means that you can share mass memory, files, and other programs with the other computers.
Yes, the user cannot see the network, but can use all its resources.
Hey, Paul, come and see. Tuomas has some interesting things displayed.
Oh, gee, what game is this? In our laboratory, the most popular game is Hack.
Well, actually, I have to worry about selling the product. the seeing robot, I mean. I've been using this multigraph program to project possible sales, costs and profits on the screen.
I would have needed that for filing my income tax form.
It's good for that too, and keeping your bank account balanced. In this pie diagram here, you can see the leading robot manufacturers in the world.
Can you plot it out?
Yes, if you have a plotter or some other peripheral device.
If we could just take a piece of that pie.
Well, you mean like this?
You seem to have very good project management tools. I think we can have faith that we can carry out this project successfully.
Tonight we will take you to a Finnish sauna bath to really test you.
Me? To a Finnish sauna?
Sure.
Must be too hot for me. Oh, maybe if I can take my portable computer with me.
Hey.
Hey, you got a robot manipulator here. Is it also a member of the project team?
No, it's not. This is a standard industrial robot. There is a slave microprocessor to control each joint, and also a master computer.
In computer world, things are often like in ancient Rome. There are masters and there are slaves. The master computer gives commands to the slave computer, and the slave computer accomplishes the task.
A vision system produces digital images of its surroundings.
And you could have pattern recognition capability too.
Computer works digitally. Think of a TV screen and divide it into small squares called pixels. Feed this information to the computer and you have a digital image of the screen. Really a string of numbers. The computer can deal with this. It can identify shapes and other features from this image. It can do pattern recognition. You know quite well what we want.
But all this requires a big mainframe computer. Maybe a supercomputer for number crunching.
Supercomputers are the fastest computers available in the world. They are used for weather prediction and predicting earthquakes. Parallel processing is used in supercomputers, the simultaneous execution of many instructions. In this way, the computers will really crunch numbers. They are tremendously fast. Instead of having one long train on one track, you have several short trains on parallel tracks.
Real-time picture processing and control of a robot. How could we do it?
If you are driving your car on the road, that is real-time control. You observe the environment all the time and make decisions online. This car was not controllable. It is the same thing with a computer-controlled robot. It senses or measures what happens around it The computer gets the information and controls the robot practically in real time. Here, the robot was not controlled very well. We will build an interface between the computer and the real world. In this case, it's the robot and the vision system. Voila, we have a seeing robot. Before the computer can do anything, it has to know about the world around it. The bridge must exist between the robot and the computer. This is called the interface between the computer and any other device, in this case, the robot. So let's go through the software management phases once again.
We'll start by defining what we want. Things like interface software, control software, and picture processing software.
Right. Software management is extremely important. After the definition phase comes
Design phase. We'll decide what language is to be used. BASIC is too simple in this application. Fortran, Pascal, C, Ada, and so on. And what operating system we'll use?
We have decided to use the C language with a Unix operating system as the development environment.
Then we will draw flowcharts.
No, that is old-fashioned. We must first define what sort of modules the program consists of. Like Jarmo said, interface modules, control modules, and so on. We start from the intelligence aspects of the robot and come down, the top-down method.
Top-down method proceeds from the high level up, down. If you think of the automobile evolvement, it has proceeded from bottom up. First, wheels were attached to the body, then the engine was developed. Finally, the microprocessors have entered the picture. Thinking of top-down method, you ask the question, I want to go from one place to another on the road. How should my automobile look like? Keeping in mind the current day technology, would the automobile be the same as it is right now?
Then we'll start programming, coding, and testing.
Right again. In this way, it's easier to test and find bugs in your program. Bugs are not only small blood-sucking insects, but also errors in your computer program, really annoying beasts. Debugging means locating these errors and correcting them.
Coding is done with our mainframe computer. Then we'll install the program in the robot's microcomputers and test it with the hardware.
Yes, you seem to be catching on with the software management very well. But one thing that I forgot to emphasize is documentation.
I'm glad you said that. Most of the time, people do not understand that it is essential to write down clearly what you have done.
Documentation. Oh, how I could cry. People still ignore it. It is so important to tell what your program does by writing comments in plain English, drawing flowcharts, and so on. How else do you think that people would know what your program does? They don't. You have to tell them how to use it, what it is for, and how to test it. This is documentation. Don't you forget it.
Yes. and we have a versatile word processing system to aid in that. Taina, tell us how it works, please.
Sure. Edix works like a paper, pencil, and an eraser combined. Once we have written the text in a file, we edit it, add phrases, remove them, and there is windowing too.
Old typewriters were beastly, because all the mistakes that you made appeared immediately on the paper, and I made a lot of them. They were very hard to correct, but with word processing, you first type your text on the screen, edit it, make corrections there, move paragraphs around, and so on. With Windows, you can have a look at the beginning of the text and the end of the text at the same time. Windowing is like having a peephole to many different rooms at the same time. It's beautiful.
For software development, we have here workstations that are connected to other computers via communications bus.
Here is the whole computer network, a local area network.
This means that you can share mass memory, files, and other programs with the other computers.
Yes, the user cannot see the network, but can use all its resources.
Communications bus is not a bus for transporting people. It's for data. It's a data highway where you transport numbers, messages. So bits are transmitted through coaxial cables, either in serial or parallel form. Parallel transmission via parallel cables is used for short distances. For longer distances, many parallel cables would cost too much. Therefore, serial transmission is used. One message is sent after another. Computer network consists of many computers and peripheral devices. It used to be so that different computers did not understand each other. They had a problem of communication, like people often have. Local area networks, LANs, changed all this. They tie different devices together and make communication possible. Ethernet was one of the earliest local area networks. There, the device sent a message on the communication bus, and if another device happened to send a message at the same time, a collision occurred. All messages were stopped. And after that, the one that had higher priority took over and sent its message again, and so on. Computer itself has only a little bit of memory, just like human beings. We store data and knowledge into books and music on cassette tapes and records. The computer also uses cassettes and disks as mass memory devices. Communication with a computer is not easy. The computer does not listen to you. You have to write a program, and if you key it wrong, the computer becomes angry because it did not understand you. In the future, we can use voice synthesizers and just talk with the computer, and the computer talks back to you.